Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. All right, welcome to the very first official episode of the Automotive Diagnostic Podcast, episode number 1. What we're going to be talking about today is something I think is very important for any diagnostic technician, automotive technician to have, is a diagnostic process. And what this is a process that you go through for every vehicle that's in your bay where you're trying to solve a problem. You're trying to diagnose something, get an answer, what needs to be repaired. This isn't necessarily for the repair itself, but figuring out what the problem is. And I think having a process that you follow every time that can be applied to any situation. I mean, the process that I use, I can use it on a suspension noise. I can use it on a CAN bus communication issue. I can use it on a drivability issue for the engine. Doesn't matter. I can apply this process in multiple ways. But when you do that repetitively and you follow all the steps in your process, it's going to help you to not miss anything along the way. I can tell you it's done that for me for sure. Now, it took me quite a few years to develop this process and actually put it down onto paper. I don't have to pull the paper out every time now. I've done it so many times. I know my own by heart. But once I was able to create that, it really helped me efficiently diagnose vehicles and not miss any things. And I can tell you, when I do miss something, when I misdiagnose something, or, I just get my butt kicked and I have to go back to square one, it can almost always be attributed to the fact that I skipped one of my steps. One of my own steps in my own process, I didn't follow it, and kind of led me down the wrong path for a while. So what I'm going to do is I'm going to go through my process that I use for every vehicle that I diagnose. And I'd like to think about your own process, if you have one, as we're going through this. And then at the end, I'm going to challenge you to actually jot down your process on a piece of paper. Keep it in your toolbox, or some place that you can reference it until you've got it down by heart, and you follow all those steps. So with that, let's jump into it. I'm going to go through step by step here on my personal diagnostic process. Now, I should mention too, there's no reason everybody has to follow this exact process. You should have your own, something that you're comfortable with, something that works for you. I just want to give you this as an example. And again, I built this over years of doing it. Bits and pieces I've taken from training classes, from personal experiences, from service information, whatever it might be, to build something that works for me. It's not necessarily something that's going to work exactly for you, but might get you started thinking about how you can create your own, or what pieces of this you might want to use. So step 1 is understand the issue or concern. Why is that vehicle in your bay? Now, sometimes this is very easy. If the engine doesn't start, okay, well, that's why it's in your bay. The engine does not start. But let me tell you, there have been many, many times where there is a lack of communication between me and my customer. That lack of communication could be the service writer. It could even be me, too. Maybe I didn't ask the right questions. But it's important to know why the customer brought that vehicle into the shop and exactly why they brought the vehicle into the shop. Talking to the customer is huge here in understanding. Now, the easiest way to reference this is, let's say, a suspension noise. Suspension noises can be pretty easy to diagnose. That's not really what this podcast is about. But we would have a customer bring the vehicle into the shop and say, hey, I want to fix the suspension noise that's in the front of my car. It kind of goes clunk. Okay, that's what's on the ticket, or that's what I heard from the customer. So I go and I drive the test drive the vehicle, take it for a drive. I hear this really, really loud clunk from the front. Okay, sounds like a ball joint. Put on the hoist. The ball joint's just, smoked. all kinds of play, safety concern. Okay, let's put this ball joint in here and put the ball joint in, okay, with the customer, align it, get it out the door. Customer comes right back and says, hey, my noise is still there. That noise that I wanted you to fix is still there. And, you explain, okay, well, the ball joint was really loose, this and that. And they're not happy because that's not the reason they brought it in. And you go back and you go on a test drive with them, and there's a little tiny clunk coming from a sway bar link or something like that. Now, obviously, you should check out the front end and recommend all the loose parts. That, again, that's not the point of this. The point of it is the customer is going to have something specific that they're bringing the vehicle in for. And you need to understand that. You need to understand why exactly they're bringing it in, what is their exact concern. So some things, again, are simple. Hey, my check engine light's on. Okay, let's solve that. But maybe it's that their check engine light's been on for 6 months, but it was flashing the day before. Those little pieces of information really make a big difference when you're actually trying to solve the problem. So that's the very first thing I want to know is, what is the actual concern? Why is this car in my bay? All right, so number 2 is to get all the information. I mean, all the information that you can. Before I proceed on actually trying to figure out what the problem is, I want to get the story, the background on this car that's in my bay. So previous repair history is huge if the car has been in your shop, or if you have access to the previous repair history. I want to know who worked on this before. Heck, was it me? Was it another shop? Where's it been? What's been done? Who touched it? What's been attempted to be fixed before? This can save you a lot of time, because there could be something where a previous repair has led to why it's in your shop right now. Or maybe somebody was attempting to fix the same problem before and they were unsuccessful. Lots of things like that. So I want to look at repair history. This goes back to the first one too, but talk to the customer. Ask them, how long has this problem been going on? Have you had it diagnosed or repaired by anybody else to try to fix this problem? That customer information is huge, huge, huge. When I was in the field, I really, really wanted to talk in person, me to the customer, rather than just taking my service writers what they'd write up on the ticket for me, because man, there are some little key pieces of information that you can get just by talking to the customer directly, getting the information from there. As a technician, we pick up on little things, maybe just one word that the customer says that maybe our service writer doesn't pick up on. I'm not picking on service writers, but we're the technicians. We're the ones actually making the repairs, and those little pieces of information are huge to us. Now, you may not have direct access to the customer. Maybe you're not there when they drop it off. Maybe the shop you work at does not want you up front talking to customers. That's fine. You can communicate with your service writer to ask the right questions, or you can create or find basically a customer interview sheet. And these can vary depending on what you do. I mean, do you do a lot of suspension noise work, or are you the drivability electrical guy? They'll change the questions, but you can have a set of questions. When does the problem occur? How long has this problem been happening? Have them describe the problem in detail in their own words on this interview sheet, and then have the service writer put that in with a ticket. And again, you can get a lot of really good information this way, all depending on how in-depth your questioning is and what information you get out of the customer. Really, really important to just talk to that customer in some way, shape, or form. Get on the phone and see what they have to say. It has solved the problem for me many, many times. One example, Ford F-150, the Triton motor. This is earlier in my career, comes in, it's misfiring like crazy. Service writer says, yeah, he's been messing around with this truck, trying to get rid of this misfire. He can't. So I'm messing around the truck, just getting my butt kicked. I have random misfires, all cylinders, okay, 1 through 8. And I take a look at the spark plugs, and they're brand new. And my service writer's like, yeah, he put in plugs to try to fix this, and it didn't do it. Okay, so I'm chasing my tail and chasing my tail and chasing my tail, and nothing seems to be making this thing, the misfires go away, and I can't really place what's making these random misfires occur. And so eventually, and I didn't have a scope at this point. This is quite a long time ago where I would have been able to spot this as more of a parts swapping diagnosis style at that point in my career. But anyways, I call the customer finally after hours of messing around with this thing, and I'm just trying to figure out, like, how long has this been going on, and trying to get a little bit of history about this. And the customer says, well, I put in these new spark plugs that I got from whatever auto parts place, and after that it started misfiring like this. I was like, oh, okay. That wasn't the information that I got. And that one piece of information was what I needed. I got some Motorcraft spark plugs, put them in there. Boom, took care of the misfires. Okay. Easy enough problem to solve, but if I would have just talked to the customer in person, or asked them the right question in person right away, or maybe had them fill out an interview sheet, I would have saved hours of my day. So just one example of where that can come into play. All right, on to number 3. Let's verify the concern. Once again, this can be very easy. If it's a hard fault, like a no start, okay, the engine doesn't crank, let's verify it doesn't crank. Okay, that's easy, not much to that. But let's say it's an intermittent concern, something that does not happen all the time. That's where this step, number 3, verifying the concern, can get very, very challenging. And our goal as a technician is to try to duplicate that concern over and over again and have a consistent way to duplicate it. Because if you don't have a consistent way of duplicating it, you're not going to be able to verify that you fix the problem after you're done. So I really like to take some time here, if it's an intermittent problem, and really try to mimic the conditions, figure out exactly what's happening when this problem occurs if it's intermittent, so that I can do that again after I've made the fix. Really, really important to verify the concern before you move on. All right, number 4, before I get under the hood and start doing any actual testing, I'm going to check for technical service bulletins and common issues. All right, I'm not a big pattern failure guy, but I think all of us know how big technical service bulletins or known problems are going to be. You don't want to just go hop on Identifix and, there's 50 hits for ignition coil, let's slap a coil on it. That's not what I mean here. But if there's 50 hits for an ignition coil on Identifix, that might be the first thing that I actually test. Service bulletins are going to point to things like, you need a software update to correct this issue. For instance, AC compressor noise on a GMC Yukon is repaired by updating the software for the PCM so it applies the clutch at a different time. That's going to take you a long, long time. I don't know that I'd be able to find that without a service bulletin to help me out there. So anytime I'm going to pop on, I'm going to look for service bulletins, I'm going to look for known problems, use whatever resources you have available in your service information to do that. But it's an important step that will save you some time. Now, again, that does not mean that you skip to the end here by throwing a part on it or just guessing at a software update, but it will point you in the right direction, and you can make your testing more efficient this way, so that you jump right into the correct area because you've taken your time to do the research here. Okay, number 5. Now, number 5 will change as you gain experience, or if you gain experience on a certain make or model. Okay, you may work on a certain vehicle over and over again, and number 5 is really kind of built into your experience at that point. But here's what number 5 is: to understand how the system or component works normally. And let's just take something like an ignition coil, something very simple, something most of us understand how our ignition coil works. We make a magnetic field, we collapse the magnetic field, that induces a voltage spike, which jumps across the spark plug and ignites the air-fuel mixture. Okay, that's how an ignition coil works, but let's say we did not know how ignition coil worked. Let's say this is a new component that's never been on an engine before. We don't want to just jump into the testing and jump into let's check for powers and grounds and stuff if we don't really know what that coil is supposed to be doing. Okay, and we run into this a lot in the automotive field, especially nowadays. There's your new cars, new systems, new technology, things that we haven't seen before. I'm not extremely familiar with newer variable valve lift systems that are coming out on a lot of these engines. So if I'm going to try to diagnose one, I need to take the time here to do the research and really understand. If it's an electrical problem, I'm almost always going to pull up a wiring diagram before I even open the hood or pull the car in. I mean, depending on if I know it's an electrical problem right off the bat, but I need to study that diagram. I need to know, how does this circuit work normally? Where are the powers? Where are the grounds? What's going on with this before I actually jump into testing? And this may seem simple enough, again, because, as we gain experience, we know how these systems work. But there's so many variations and so many different vehicles out there that you can't have all of this up in the top of your head. Reviewing the service information before you jump in is huge here. And one other thing too is, you may think, okay, I worked on a 2007 Silverado a couple months ago and this system worked this way. Well, the 2010 that's in your bay now may not be exactly the same. They change things so quickly in this field that you can't just assume that you know how this component or system works. So take a look for that description and operation in your service info and do some research. Figure out how that thing is supposed to work and have a good understanding of it before you go to test it. Because if you know how it normally works and what it's normally supposed to do, the time when it acts up or the problem is going to stand out pretty clearly to you. So that's number 5, understand how the system component normally works. Number 6, this is a big one. This is a big one that I mentioned. If you skip steps in your process, if I skip steps in my process, it usually leads me to missing something. Well, here's a huge one that has kicked my butt before. It's a visual inspection. Now this will vary depending on what you're working on. You can't see electrons in a wire, but you can see some corrosion on a wire. You can see broken wire, things like that. Visual inspection, man, this is huge. It's so simple, but it's overlooked by a lot of people. I've seen a lot of technicians just plain and simple skip this step. And I watched a guy, pretty well experienced, waste an hour of his time on an ABS issue without ever lifting it up and looking at the sensor. Well, it was unplugged for whatever reason. I don't know. Somebody unplugged the wheel speed sensor. Okay, a visual inspection would have solved that in a matter of minutes. Take the time here, whatever component, whatever system you're working on, give it a good visual inspection. I got my butt kicked on a misfire issue on a General Motors vehicle years ago, and the reason was a worn down camshaft lobe. Now you can't see that with the engine intact, but I had the engine apart far enough to see this cam lobe, and I never looked at it. And I'll never forget that because I did not use a good visual inspection of that system. And that's all it would have taken. It would have saved me hours and hours of messing around by performing a good visual inspection. So take a look at what you're working on. Put your eyes on it, and that is going to help you a lot. All right, number 7. Like I said, I have gained some of my steps from my process over the years by training and by listening to other people. And Jim Morton actually has some really good stuff on this where he talks about staying in a funnel. Get yourself, use some general test procedures and go into a funnel and stay into your funnel. If it's air, fuel, and spark in an engine, figure out which one you're missing. And then if it's spark, stay in that funnel. Keep testing spark till you figure out what's wrong. Don't jump out and go to fuel. I really like his analogy there. But what my step is here is exactly that. Stay focused on the problem that you have. Don't second guess yourself. Don't jump around. And if it's a problem, let's say an electrical problem where there's 5 or 6 components that don't work, what I like to do is I like to focus on one of those components. Okay, pick one. Let's say the turn signals, the power windows, the door locks, and the headlights all don't function. I'm going to pick one. I'm going to go after the headlights. I'm going to figure out what's wrong with them. And odds are, if this all happened at the same time, I'm probably going to find the source of all the problems. If you do 3 or 4 tests on one area and then kind of come to a dead end, the next step's going to be challenging, let me jump back out and I'll go test these components. I'll do 3 or 4 tests on the door locks now instead of the headlights. You're going to waste a lot of time. So stay focused. As Jim Morton says, get in your funnel and stay in it. That is going to make your diagnosis process much more efficient if you do that. So stay in your funnel, as Jim says. Number 8, I like to have more than one way to test my failed component. Okay, if I have something that's failed, sometimes it's pretty obvious. Okay, broken wire is broken wire. If a component is melted, a component is melted, but we don't always get that lucky in this field. Sometimes visually there's nothing wrong with the component. Many, control modules, you're not going to have a whole lot of visual confirmation that they're failed if they're not melted or corroded. We need multiple ways of proving out a failed component. Now, this is pretty wide-ranging, and this is where some experimentation comes into play, where having some known goods available are important. But having multiple ways to prove out a failed component is going to increase your success rate of your diagnosis by quite a bit. So one suggestion I have here, because this is not necessarily an easy step, is let's say you make a really easy slam dunk diagnosis, okay? You figure out that ignition coil is causing a misfire. Pretty simple. Once you do that and you have that failed component, play around with it. Do some different tests, and then do some different tests, those same tests with the new component, and see how they differ. Have 3 different ways to prove to yourself that ignition coil has failed. I'm not a big fan of ohm checking, but let's say it fails the ohm check, and then you use a spark tester, and you can come up with different ways, compare the 2 tests to themselves. That ignition coil's failed. Okay, this is pretty simple, pretty standard stuff, but compare your 2 tests from the old part to the new part, and it's going to help you in the future when you're not so sure, is that component really failed, or am I just taking a guess at it? Having those multiple test methods is really, really important to help you along. All right, on to number 9. You figured out what the failed component or what the problem is. You do always want to ask yourself, what is the root cause of this problem? Okay, did this control module just melt? Or is there something else, behind this? Is there something else that's causing it? Did the driver and the PCM fail? Or was it an ignition coil or a fuel injector pulling too many amps that caused that driver to fail? That sort of thing. So always ask yourself that question when you're replacing a component. And again, sometimes it's just a component, okay? Sometimes things just plain and simple fail. But a lot of the times in this field, you'll see a cause and effect. You'll see components that cause other components to fail. You replace that failed component and then ends up failing again down the line. You replace the GM fuel pump, but you didn't do the filter, and the pump ends up failing 6 months later because of that. So ask yourself, what is the root cause of the problem? That's number 9. Number 10, this one's pretty easy. Determine and execute the solution. Okay, what's it going to take to fix it? Do I got to solder this wire? Do I have to put a control module in it? Do I have to update the software? Okay, and then do it. 10's pretty easy. But I guess if you didn't do number 10, well, you're not fixing the car. So, and 11, again, this is most of the time pretty simple. But this goes back to step number 3 where we verified the concern. Number 11 is to verify the repair, to actually make sure that you fixed it. Take it on a test drive. Stress that component that you put in there. Make sure that it's actually working correctly, that it's doing its job, and test it multiple times. It's funny how some things can work one time, and then as soon as the customer gets in there, it stops working. You need to make sure that it's going to be fixed. It's going to be ready to go back out on the road. So, verifying a repair. Those are our 11 steps, or my 11 steps for my diagnostic process. How I go through, and like I said, when I misdiagnose something or when I'm wasting time chasing my tail, it can usually be attributed to the fact that I did not follow one of these steps. So I go back and take a look at my process. Where did I mess up? Where did I skip ahead or jump over my process? One other thing I'd like to add to this, and I have this written on the back of my diagnostic process, is it's an addendum. Okay, some added things that I've thrown in it over the years that don't necessarily have a specific point in the process, but things that I have to think about during the entire process. Number 1, there's no such thing as a new part. I'm sure all of us have been burnt by a new part. Aftermarket parts are well known for, especially electronic components, well known for having issues. There are certain brands out there that are just not up to the standards. And yeah, it's new, it's shiny. It was sealed up in the box when you got it, but that does not mean that it's going to be a good part. I've been burnt so many times by good parts. Just because you put something on there, just because someone else put something on there, doesn't mean that you can just completely ignore that part. Okay. I've really second guessed my own diagnosis because of these parts. I'll put something in, a new part, and then it doesn't work. It may even have the same issue as the part that I took out. That's where it can really throw you. And so I go back over all my steps, and I'm like, what am I missing? Well, it's a component that I put in there. So no such thing as a new part. You'd like to think that there would be, and most of the time you're okay, but depending on where you're getting parts from, man, that can be a hassle. So keep that in mind, that you can't forget about that new part that's in there. Number 2 on my addendum is, what's the validity of my testing procedure? We develop a lot of different testing procedures over the years. We use a lot of different tools and equipment. And sometimes we create our own new tests because this is a new system. This is something we haven't run into before. And the test A worked great on the last vehicle that you worked on, but it may not be a valid test on the vehicle that you're working on now, or the system component that you're working on now in this newer, or who knows, maybe an older vehicle. Doesn't matter. Everything's different. You need to just ask yourself quick, what's the validity of this test? Is this test, the results I'm getting from this test, do they really mean what I think they mean? And again, that comes with experience. You've got to do a lot of experimentation, known goods, performing. If you're going to add a new test to your skill set, you're testing out components. What's really a good idea is to do it on a working car that doesn't have any problems, and see what the test results are, and understand what they look like when it's functioning correctly. And then once you have a car that's not functioning correctly, you'll know what to expect, what you should see from that test result. So validity of your test is very important. And this kind of feeds into the same one. But number 3 is knowing the limitation of your tests and equipment. And equipment is the key here. Every single piece of diagnostic equipment has its limitations. It has a point where it is limited and you've got to do something else. Scan tools, scopes, test lights, voltmeters, whatever it might be, they're limited in some way. And that's why we have, multiple pieces of equipment so we can test in different ways. But each piece of equipment has its limitations. Good examples, an ohm meter. A lot of people frown on an ohm meter. Of course, then there's manufacturer flowcharts who love the ohm meter. I'm somewhere in the middle. It has its purpose. I use my ohm meter on a frequent basis, but you got to understand the limitations of it. You got to understand that's not loading the circuit, okay? But if I want to check the resistance of a CAN bus network, that's my tool. That's what I'm going for, and I don't think that there's a better one to do that. So it's just an example of understanding the limitation of your tool. I'm not going to use an ohm meter to find resistance in a power wire to a headlight. I want to actually load that circuit. But that's just one example of understanding the limitations of your testing equipment and realizing that everything does have its limits. And the final one to my addendum is to keep it simple. We try to get maybe a little too advanced, a little too excited with the new test equipment or test procedures. Quite honestly, a lot of problems are solved by going back to the basics. Simple stuff. Basic electrical, basic engine operation, air in, squeeze, air out, that sort of stuff. Bring it back to the basics, and a lot of the time you're going to find your issue that you've been chasing. So that's it for my diagnostic process and the addendum that I have to it. So I encourage you to think about what pieces of this that you can or maybe already do use in your process and come up with your own. If you don't have it written down, take some time, take out a piece of notebook paper or open a Word document and type out your personal process that you use, and save it on in your phone, or take a picture of it or put it in your toolbox or whatever works for you. And until you get it down to where you have it by heart, refer back to that process and ask yourself, am I skipping any of these steps? Are all of these steps needed on every vehicle that I work on? I think it has really helped to make my diagnosis of issues more efficient and more accurate over the years. So that's it for episode number 1, the diagnostic process. Thank you for tuning in. Thank you for listening, and hope to see you again soon.